Okay. We're not dealing with i's yet. We're only dealing with radicals, so you can't have a radical in the denominator. How do we cancel a square root? We need it squared. However, with fractions, you can't just square top and bottom. It's not equal. So how do I create something that's squared? Well, to create something squared, don't you have to multiply it just by itself? Aren't these the same thing? Yeah. So if I multiply the denominator by itself, it's creating a squared to cancel my square root. Yes? So same concept with cubes. If I have cubes, I can create a cube by multiplying by itself twice, which we'll get there and I'll show you what I'm talking about. So if you look at number 1, we have 7 over the square root of 7. I cannot have a square root in the denominator. So I need to make that squared. Well, the only way to do that is to multiply it by itself. Well, what I do to the bottom, I have to do to the top to keep it equal, yes? So I'm just going to look at the bottom for now. We're going to simplify one side at a time. Okay, so we have, do we have the square root of 7 twice? Mm-hmm. Yeah, so I can write this as 7 squared, the square root of 7 squared. However, if you wanted to, you could technically multiply them because they're both under a house. What's 7 times 7? 49. Okay. Doesn't my square root cancel my square root? And what does this equal? 7. Well, what's the square root of 49? 7. So does it matter if you wrote it as squared or if you multiplied it and combined it? No, because it's going to give you the same answer. Okay. Now on the top we have 7 on the outside and a 7 on the inside, so they cannot combine. So it just is itself. Well, what happens here?
Oh, they cancel.
They cancel, and what's my answer? It's just the square root of 7.
We did all that just to get to
We
the
did.
square root of 7.
Yep. We did.
Well, we could have just said it is the.
Miss Lou canceled on that side. Just the square roots.
Okay, look at number 2. Same concept. Technically you could simplify this, but we're just going to hold off till the end. Okay. So we have a square root again, so we just need to multiply by the denominator. What I do the bottom, I have to do the top. So now I have, don't I have the square root of 27x twice? Mm-hmm. So I can write it as the square root of 27x squared. So on top I have 9 times the square root of 27x. Well, let's just focus on the bottom for a second. Square root cancels my squared. And what am I left with in the denominator? 27x. However, we need to see if this 27 breaks down. So I'm going to come over here. What goes into 27? Not 2. 3. 9 times. 9 is a perfect square of 3 and 3. So I have a square root, so I need something to match twice. And whatever's left over goes back in the radical. So I already have a 9, but what did I just take out?
3.
A 3, and what was left over? 3, but what can I not forget? X. What's 9 times 3?
27.
So my 27s cancel, and I'm left with the square root of 3x over x.
Wish you're on the road to 30 subscribers.
Okay, shh. Any questions with that? Okay, so let's look at the next one. What's different about this one? It's cubed. So I need 3 to cancel, yes? So I know, there it is. Couldn't find my pen. I have 2 ones. How many more 2s do I need?
1.
Because this is technically 1. I know I have a cube root, so I need a cube to cancel. So I need 2 more 2s, right? That will create 3 together. So I'm going to multiply by the cube root of 2 squared on top and bottom. Oops, squared, sorry. Because if I put these together, I have the cube root of 2 to the first power times 2 to the second power. When my bases match, what would we do with the exponents? And I'm multiplying. We add them, so this becomes the cube root of 2 3 times, because 1 plus 2 is 3. Remember, you don't multiply the 2's because you have to follow the law of exponents first. Well, what happens to the cube root and the cube? They cancel, and what am I left with in my denominator? 2. So now we're going to simplify the numerator. I have 4 cube root of, what's 2 squared? 4. Now 4 doesn't break down because it's just 2 and 2, and this is a cube root. So it's just 4 cube root of 4. And what's 4 divided by 2?
2. See, I feel like this one has
Okay, so look at number 4. Okay, we have a cube root again. It does make it a little easier to separate cube root of 4 over cube root of 3p. However, if you don't write it separated, it's fine. It's the same concept. And I know I need to get rid of this 3p. Well, right now I have 3p one time. How many times do I need it to cancel my cube root? 3. So how many more do I need?
2.
2. So I have the cube root 3p twice. I'm going to focus just on the bottom. So I have 3p to the first plus 3p to the second, or I'm adding the exponent, sorry, not multiplying those. And I get the cube root of 3p 3 times. Yes? And so the cube root cancels my cube, and I'm left with 3p. However, on the top, I can combine these because they're both inside of a cube root, right? So I get the cube root of 4 times, well, what's 3p squared? 9p squared. Because 3p twice is 3p times 3p, so 9, and then p twice is p squared. Yes? What's 4 times 9? So I get 36p squared. And we have to just make sure that that doesn't simplify. So we can break down our 36. I know 2 goes into 36 18 times. 2 and 9, 3 and 3. Well, this is a cube root. Does anything match 3 times?
No.
No, so this is my simplified answer. 3 doesn't go into 2, so we're done. Okay, so when you're done doing that, I want you to flip to the next page. And I'm going to show y'all something from yesterday. Okay, yesterday's practice, if you made it to number 7 and 8, look like this. Okay, we have this for number 7. Remember, when you multiply by something, we've seen this before, like x plus 2x minus 2. Remember, we called that the difference of squares when you multiplied, because it would give you x squared minus 4. Okay, it was a perfect square minus perfect square. I know these aren't squares, okay, but it's the same concept. When you have something and you multiply by what it matches by, those middle two terms are always going to cancel and leave you with a number, and there's no more radical. Yes? Well, look, here's another one. Did it do the exact same thing? Yes. So that happens every time when you multiply by the same thing with a different plus or minus sign. Yes. Okay, so we call that the conjugate. So that's a fancy word. It's right here. You must multiply by the conjugate. Okay, so what is the conjugate of this? Well, it already has minus. So it's going to be plus 2 root 3. So 7 plus 2 root 3. Well, what I multiply the bottom by, I also have to multiply the top by to keep it equal. Now, we're not going to multiply the 4 in, because what if it simplifies later? Do y'all really want to do all that work to multiply it in to turn around and take it back out? No. but on the bottom we are going to have to double distribute. So what is 7 times 7? 49. And those are not in a house, so do not put a house. What's 7 times 2 root 3? Yeah, positive 14 root 3. Because there was no other root with that 7 to change it. So then I have negative 2 root 3 times 7. Negative 14 root 3. And then I have negative 2 root 3 times positive 2 root 3. What's 2 times 2?
4.
So negative 4 because of negative 2 times 2. And then what's 3 times 3 on the inside? 9. Remember, you can multiply if they're both in the house. Any questions with what I've done so far? Okay, so here's my question. What happens to those middle two terms? They're like terms, but they're exactly the same in 1 plus and 1 minus. If I give you 14 and I take 14 away, how many did I give you? None. I took them all back. So this is 0. And 9 is a perfect square. So there's 2 ways to do this. You can do it by hand. We have 49 minus 4. What is the square root of 9? 3. So then we have 49 minus 12. And if you type that in your calculator, you get 37. However, if I know that this is a perfect cube and these are going to combine, or it should be a perfect cube because I multiplied by the conjugate, okay, I could type it in my calculator, 49 minus 4 square root of 9. Did it give me the exact same thing? Yes. So if you want to do it by hand, you can do it by hand. However, if you look at example 6, are we going to be able to do that one in the calculator? No, because it has an x. Okay, but if it doesn't have an x, you can. Okay, so knowing that, I have 4 times 7 plus 2 root 3 over 37. And 4 over 37 does not simplify, so you can leave it like this. However, if it's multiple choice, I want you to understand that you could technically multiply that 4 in, and you would get 28 plus 8 root 3 over 37. So you could see it both ways. Okay? As long as you understand those are the same, you're good. If you leave it like this on your practice, I'm okay with that. Okay? So looking at number 6, what are we going to multiply by to cancel our radical in the denominator? What is the conjugate of the denominator? It's going to be the square root of x plus 2. What I do to the bottom, I also have to multiply by the top. And we're going to focus on one level of this at a time. So knowing that, we're going to do the bottom. So square root of x times the square root of x. Well, what's x times x? X squared. Square root of x times positive 2. It's going to be 2 square root of x. Negative 2 times the square root of x is negative 2 square root of x. One's outside, one's inside, so they can't combine. And what's negative 2 times positive 2? Negative 4. Well, what cancels? Do the middle two cancel like we wanted? Yes, 2 minus 2 is 0. And what happens here? Yeah, the square root cancels the squared. So what am I left with in my denominator? X minus 4. Okay, so now we multiply the top. So again, square root of x times the square root of x. Square root of x squared, because x times x is x squared. Square root of x times 2 is 2 square root of x. Now I multiply the positive 2. 2 times the square root of x. So again, positive 2 square root of x. And 2 times 2 is 4. Now, do you notice they're almost exactly the same, except this has plus signs on all of them? It's just because all the numbers are the same. This one just had a minus, this one had a plus. It's the only difference. So nothing cancels on this one because they're all positive. Positives don't cancel positives. Here, my square root cancels my square, and I have an x. What's 2 plus 2?
4.
Because remember, when we're adding, the radical doesn't change, so it just stays 4 square root x. The square root of x did not change. And what, well, plus 4 doesn't change. I was about to say, what does it simplify to? But it doesn't. Here, can you cross out the x's and the 4's? No. What? Why?
Because it's connected.
The plus and the minuses make them stuck like glue, y'all. So unless you can cancel that whole piece together, you can't cancel it at all. So there's your answer. Almost done. The last one I like better than those. Okay, so look here. One thing I want you to remember is that when adding and subtracting, what do you have to have? Like, can I combine these right away? No, because they have what don't they have?
They have
The common denominator. They have to have a common denominator. And as of right now, do they have a common denominator? No. So we have to make sure we can make them have a common denominator first. So yeah, you're exactly right. We could break down 20 and we could break down 80. So let's break those down and figure out if anything's alike before we start multiplying by radicals and stuff. So 20, what goes into 20? 2 and 10. What goes into 10? 2 and 5. Both are prime, so we're done. So what do I get to take out? A 2. But what's already outside? So I have this 4 times 2 square root of 5. What's 4 times 2? So my denominator right here is 8 square root of 5. Yes?
Yep.
Everybody okay with that? So now we have to break down 80. 2 and 40, 2 and 20. Well, then I could just copy this. 2 and 10, 2 and 5. Well, here I have 2 sets of 2's that match. Okay, so what do I get to take out? 4 square root of 5, because I had a 5 left over. Now here's my question. What matches already? I forgot my question. Yeah, all of them already have a square root of 5. What part does not match right now? Yeah, the number in front. I have an 8, a 4, and technically I could put a 1 here, right? Okay, so I can never make my denominator smaller unless it simplifies. 3 over 8 does not simplify. So knowing that, can my smaller numbers turn into 8? Can 4 turn into 8? By multiplying by what?
2.
So if I multiply bottom and top by 2, is this now 8 square root of 5?
Yeah.
Yeah, 2 times 4 square root of 5 is 8 square root of 5. So look, those match now. Yes? Can I turn a 1 into an 8? By multiplying by what? 8. So if I multiply top and bottom by 8, well look, 8 times 1 is 8 square root of 5. So now are all my denominators the same? Yes, so I know that I have a common denominator of 8 square root of 5. And I need to simplify the numerator. Well, I have 3 minus, what's 2 times 6?
12.
Plus, what's 8 times 2?
16.
And can I type that in my calculator? Could I have typed it the way it was?
Yeah.
Yeah. And I get 7. Now, here's the problem. I can't simplify this, and I have a radical in the bottom. Technically, I had radicals here, right? But do you want to simplify the radicals 3 times or just once? Once, which is why we combine like terms before we worried about a radical in the denominator. But now I have to get rid of that radical. How do I do that? Multiply by itself. Am I worried about the 8? No. So I'm just worried about the square root of 5, so I'm going to multiply bottom and top by the square root of 5. And I have 7 square root of 5 over, let's figure this out. Well, what's the square root of 5 times the square root of 5? Well, we could write it as 5 squared, or you could say 25. What's the square root of 25? Doesn't the square root cancel squared and give me 5? So is my denominator 85? No, what do I have to do here? Multiply. What's 8 times 5?
40.
40. Does 7 over 40 simplify?
No.
No. There's your answer. Okay, there's one more thing I want to tell y'all. It's on your practice, so I'm helping you with your practice. There are 4 of them that you could do with this thought process. So if you look at number 4, 5, 6, and 7 can be done with this thought process. I'm going to look at 2 of them with you. Okay, so if you start at number 4. I know that these aren't separated, and that's okay. This is a square root, which means a 2. Does 2 go into 3 to cancel the radical on the bottom? No. Okay, what's your next number after 3? 4. Does 2 go into 4? So how many more r's do I need? Just 1. I don't have to multiply by itself because, I mean, you could. You'll get 6, r to the 6th power, which does simplify, but you'll just have to simplify at the end. So if you do the less, you'll have less simplifying. Does that make sense? Okay. So knowing that, I can multiply by just the square root of r, top and bottom. Well, 3 plus 1 is the square root of r to the 4th power. And 2 goes into 4 how many times? 2. So my denominator is no longer a radical. Don't overthink the top. Those just go under the house together. We have G3, H4R, and this is a square root. 2 goes into 3 how many times? 2 goes into 4 how many times? 2 goes into 1 how many times? Does that make sense? How many times can I simplify G? How many can I take out? 1, with how many left over? 1, because 2 goes into 3 one time with 1 remaining. If you need to draw it, there's my 1 that I get to take out. There's my 1 that goes back in. What about 4? 2 goes into 4 how many times? So h squared. Did it have a remainder? Does 2 go into 1? So that r just stays. Okay, look at number 6. Okay, I could leave this as is, and I could multiply by the cube root of 9 squared, because that would give me 3 9s, right? But here's my question. Could I rewrite this like this? Is 3 squared 9? Mathematically, have I changed anything? No, this still equals that. So if I already have 2 3s, how many more do I need to get a cube? 1. So what I want you to realize here is the cube root of 3 squared times 3 to the 1st. Remember, when the bases match, we add the exponents. So that's 3 to the 3rd power. Yes? And on the top, can I just combine them? Yeah, well here, the cube root cancels the cube, and I'm left with 3. And what's 11 times 3? Which doesn't break down, y'all, because the only thing that multiplies to give you 33 is 3 and 11, which are both prime. So this is your answer. Okay, so number 5 and 7 can be done with that same thought process. But that's just kind of giving you a different method to look at. It's the same method, just look at it differently.